Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for February-March 2021. So let's get started. Question 1 says a student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus, either the measuring cylinder containing water or the balance. No, we do not need the balance to measure the volume. So balance only, also rejected. Neither the measuring cylinder nor the balance. No, we need the measuring cylinder. So the measuring cylinder containing water only. So the answer is B. Question 2 says a ball hits a bat with a velocity of 30 meters per second and leaves the bat traveling with a velocity 20 meters per second in the opposite direction. The ball is in contact with the bat for 0.10 seconds. What is the magnitude of the acceleration of the ball? So the acceleration is equal to change in velocity over time. So the final velocity was 20 and the initial velocity was 30 in the opposite direction. So negative 30 over the time 0.10. That gives an answer of 500 meters per second squared. So the answer is D. Question 3 says a train begins a journey from a station and travels 60 kilometers in a time of 20 minutes. What is the average speed of the train? So speed is equal to distance over time, or total distance divided by total time for average. We have 60 kilometers, that's 60,000 meters, and divided by the time, which is 20 minutes multiplied by 60 seconds, since all the answers are in meters per second. And that gives an answer of 50 meters per second, so it is C. Question 4 says, which statement about mass is correct? A mass of 10 kilograms weighs 1 Newton near the Earth's surface. So if we multiply the mass by G is 9.8 and was 10 in that exam. So it would be 100 newtons, not 1 Newton. So this is wrong. Mass is a gravitational force. Mass is not a force. It is the amount of substance. Mass increases when the gravitational field strength increases. No, it's weight that increases with field strength. The greater the mass of a body, the more it resists a change in its motion. Yes, that is called inertia, so the answer is D. Question 5 says a small bottle has a mass of 20 grams. When empty, the volume of the bottle is 10 centimeters cubed. When full of liquid, the total mass is 150 grams. What is the density of the liquid? So we need the mass of the liquid, so we subtract 150 minus 20 to get the mass of the liquid, and then divide by the volume, which is 10. That gives an answer of 13 grams per centimeter cubed, so the answer is C. Question 6 says an object of mass 0.80 kilograms is moving in a straight line at a velocity of 2 meters per second. A force exerted on the object in the direction of motion for a period of 1 minute, and the velocity of the object increases to 6 meters per second. What force is exerted on the object? We can say that the force is equal to the change in momentum over time. So it is the mass multiplied by the change in velocity over time, or mass times acceleration. So we have the mass 0.80 and we have the final velocity 6, initial velocity 2, and time 1 minute is 60 seconds. That gives an answer of 0.053 newtons, so we choose A. Question 7 says an object moves at constant speed in the circular path shown. Which statement about the acceleration of the object when it is at point P is correct? So the acceleration is in the direction of the resultant force, and for an object moving in a circular path with constant speed, the force is towards the center, so it would be in the direction Z. The acceleration in the direction X, no. The acceleration in the direction Y, no. Acceleration in direction Z, yes. The object is not accelerating. Yes, it is accelerating because there is a change in direction, so there is a change in velocity. So here we choose C. Question 8 says an object is pivoted at point P. A student ties a length of string to a peg on the object. He pulls the string with a force F. What is the moment of the force F about the point P? So we need the force multiplied by the perpendicular distance from the pivot. So the distance that is perpendicular to the force is S. So it is F multiplied by S. So the answer is C. Question 9 says a gas molecule strikes the wall of a container. The molecule rebounds with the same speed. What happens to the kinetic energy and what happens to the momentum of the molecule? So the kinetic energy for the same molecule with the same mass rebounding with the same speed stays the same, because kinetic energy is half mv squared and m and v are the same. As for momentum, it is changing because the direction changed and momentum is a vector quantity. So here the answer is C. Question 10 says a horizontal force pulls a box along a horizontal surface. The box gains 30 joules of kinetic energy and 10 joules of thermal energy is produced by the friction between the box and the surface. How much work is done by the force? So we need to overcome the friction and we need to make the box gain kinetic energy. So we need to do work against this amount of energy and that amount of energy. So it is the total or the sum of both energies. So we need 40 joules. So the answer is D. Question 11 says a crane is used to lift loads vertically. The output power of the crane to lift a car is P. The crane then lifts a lorry which has 3 times the weight, so 3 times the work, of the car through 0.25 of the distance, so that's quarter the work, in 0.5 the time. What is the output power of the crane now? So power is equal to force multiplied by distance over time, or work divided by time. In the upper part we multiplied by 3 for the force, and then we multiplied by 0.25 for the distance, and then we multiplied by 0.5 in the denominator. Or we can say that the power will be multiplied by 3 times 0.25 over 0.5, which gives a ratio of 3 over 2. So we choose 3 over 2p, which is B here. Question 12 is about manometers, so you can skip this for the new syllabus. It says the diagram shows a manometer connected to a gas supply. What is the pressure of the gas supply? So it is pushing more than the atmosphere, so it is greater than the atmosphere or above the atmospheric pressure. And the difference between the pressures is from 100 to 300, that's 200 millimeters of the mercury. So it is 200 millimeters of mercury above atmospheric pressure, so the answer is C. Question 13 says the diagram shows a box of dimensions 6 by 8 by 4 centimeters. The box rests on a flat horizontal surface. On which face must the box rest in order to exert the least pressure? So we need the greatest area. So the greatest area is face X here, so we choose face X, so the answer is A. Question 14 says air in a sealed syringe is slowly compressed by moving the piston. The temperature of the air stays the same. Which statement about the air is correct? So you are compressing, which means decreasing the volume. The pressure of the air decreases? No. The pressure of the air increases? Yes, because its molecules now hit the syringe more frequently? Yes. Not travel more quickly because the temperature is constant, so the speed is constant. So the answer here is C, the increase in rate of collisions, not the speed of the molecules. Question 15 says, in an experiment, smoke particles are suspended in air and viewed through a microscope. The smoke particles move about with short random movements. Which of the following statement is correct? Air particles have large masses compared to smoke particles? No. Air particles have large masses again. Air particles move at high speeds? Yes, compared to the smoke particles, and they move in one direction only, not in one direction. They move randomly, so the answer is D. Question 16 says a graph shows how the internal energy of 1 kilogram of metal changes with temperature. So we have the internal energy in kilojoules and the temperature in degrees Celsius. What is the increase in internal energy of a block of the same metal of mass 0.25 kilograms from 40 degrees Celsius to 50 degrees Celsius? So this is the start of the 40 degrees and this is for the 50 degrees Celsius. So this is the change in internal energy from here to here. The first one is 812 and the final is 815. So the change in internal energy is actually 3 kilojoules. So this is the thermal energy for 1 kilogram. For 0.25 kilograms, we divide that by 4. So from 1 kilogram to 0.25 kilograms, we divide by 4. So the energy is also divided by 4. Dividing 3000 by 4, that gives 750 joules. So the answer is C. Question 17 says a piece of melting ice at 0 degrees Celsius and a beaker of boiling water are both in a laboratory. The laboratory is at 20 degrees Celsius. What is happening to the temperature of the melting ice and what is happening to the temperature of the boiling water? During change in state, whether it's melting, boiling, condensing, or freezing, it's all at constant temperature. So for melting it's constant and for boiling it's also constant, so the answer is A. Question 18 says one end of a copper rod is heated. What is one method by which thermal energy is transferred in the copper rod? Free electrons transfer energy from the cooler end to the hotter end, not from the cooler. Free electrons transfer energy from the hotter end to the cooler end, yes. Molecules with copper move, molecules do not move in solids, so the answer is B. Question 19 says which change will cause a decrease in the rate of radiation emitted by an object? Changing the surface color from white to black. No, actually black is a better emitter than white. Changing the surface texture from dull to shiny. Yes, shiny surfaces are worse emitters of heat radiation. Increasing the surface temperature, that increases the heat radiation. Increasing the surface area also increases heat radiation rate, so the answer here is B. Question 20 says, what is approximate wavelength in air of the highest frequency of sound that can be heard by a normal, healthy person? So if we assume the speed to be 340 meters per second, which we should know, and the highest frequency heard is 20,000 hertz, we can calculate the wavelength equal to speed over frequency. So we have 340 divided by 20,000. That gives a value of 0.017 meters, which is approximately 0.02, so we can say that the answer is A. Question 21 says, what causes a change in direction when light travels from air into glass? So the amplitude of the light changes, no. The color changes, no. The frequency changes, no. The speed changes, which is the definition of refraction, so the answer here is D. Question 22 says, light from a torch is incident on a plane mirror. The angle of incidence is 38 degrees. What is the angle of reflection? In reflection, the angle of incidence is equal to reflection. So the answer is A. Question 23 says, two rays with angle of incidence 60 degrees pass into dilute and concentrated sugar water solutions. The refractions are shown. Which row is correct? The refractive index as concentration increases, decreases or increases. So going from low concentration to high concentration, the bending increased, which means the refractive index increased. And as the bending increased, the change in speed increased. It was faster in air and slower in the liquid. So for the higher concentration, we have more bending and more decrease in speed. So the speed actually decreases in the concentrate. So the answer here is C. Question 24 says, a thin converging lens is used to produce a sharp image of a candle. Various sharp images are produced on the screen by moving the lens and the screen backwards and forward. Which statement is always correct? The image is at the principal focus? No. The image is bigger than the object? Not always. The image is closer to the lens than the object? Not always. The image is inverted? Yes. Whenever there is a converging lens and we form an image on the screen, it's always invert. So the answer here is D. Question 25 says, which row gives the approximate speeds at which ultraviolet waves travel in air and in vacuum? In air and in vacuum, they are the same for all electromagnetic waves, which is 3 times 10 to the power of 8. So the answer here is D. Question 26 says, the diagram represents a sound wave. What are the names of the part of sound wave labeled X and Y? X, we have the molecules close to each other. That's a compression. And for Y, molecules are far apart. That's a rarefaction. So the answer here is B. Question 27 says, the speed of sound is different in different states of matter. The speed of sound in liquid water is 1500 meters per second. Which row correctly compares the speed of sound in ice and speed of sound in water vapor? That's in solid and in liquid. So in solids it would be higher than 1500 and in vapor it would be less than 1500. So the answer is C. Question 28 says, 3 methods of demagnetizing a magnet are suggested. The magnet is in an east-west direction. Hitting the magnet rapidly with a hammer, that would work. Heating the magnet until it is red hot, yes. Withdraw the magnet from a coil with a direct current in it, no. With an alternating current in it. So it's 1 and 2 only, so the answer is B. Question 29 says, 3 cores of different metals, P, Q, and R, are placed inside identical coils of wire. At least one of the metals is non-magnetic. The cores are held above some iron nails. The 3 diagrams show what happens when there is a current in the coils. So for P there is no attraction at all. For Q there is attraction, and R there is attraction, which means that the core is magnetic or a magnetic material. And for the three diagrams below show what happens when the current is switched off. So when we switch off the current, P still not attracting the nails, Q lost its magnetization, and R remained magnet, so it's a hard magnetic material. Which core metals are magnetic? That's Q and R, which attract the nails. So the answer here is D. Question 30 says uncharged metal spheres X and Y rest on insulating stands and touch each other. A negatively charged plastic rod is brought near to sphere X. Using the insulation stand, sphere Y is moved away from sphere X. What are the signs and relative magnitudes of the charges induced on X and Y? So the negative charge on the rod repels the electrons from X to Y. So this will be negatively charged and leaving behind the same amount of positive charge on X. So the magnitude is equal. And for X it is positive and for Y it is negative. So the common choice here is C. Question 31 says which two changes to a metal wire both decrease its resistance? So for length we need to decrease the length, and for cross-section area increase the cross-section area in order to decrease the resistance. So the answer is B. Question 32 says there is a current I in a resistor of resistance R for a time t. The potential difference across the resistor is V. Which equation gives the energy transferred by the resistor? So energy is equal to VIT or IVT. So the answer here is D. Question 33 says a resistor R is connected in parallel with an 8 ohm resistor. The resistance of this combination is 4 ohms. What is the resistance of resistor R? We can use the equation that 1 over the total resistance in parallel is equal to 1 over one of the resistors, R1, plus the other 1 over R2. So 1 over 4 is equal to 1 over R plus 1 over 8. If we subtract the other side by 1 over 8, we get that 1 over R is equal to 1 over 8. So R would be equal to 8. So the answer is D. Question 34 says a student designs a circuit to use as a dimmer switch for a lamp. What happens to the brightness of the lamp and the potential difference across the lamp when the slider is moved from X to Y? That's going down. So this section here becomes shorter, having less resistance, and in a potential divider, less resistance means less voltage, so the brightness of the lamp also decreases. So brightness decreases and potential difference decreases. So the answer is A. Question 35 is about logic gates, so you can skip this question for the new syllabus. It says the circuit shown contains 2 gates. Which truth table describes the operation of the circuit? So we can use the gates to know the output of each point. So if the input is 0 and 0, the NOT gate converts 0 to 1, and then we have here 0 and 1, which gives from an OR gate an output 1. Now if the inputs are 0 and 1, the NOT gate will convert this to 0. Now we have 0 and 0. For an OR gate we get 0. If the upper one was 1 and the lower 1Q is 0, 0 is converted to 1 from a NOT gate. Then we have 1 and 1 entering to an OR gate, so the output would be 1. And for the last possibility, both inputs are 1, so 1 is converted to 0 from a NOT gate, 1 and 0 through an OR gate. That would give an answer of 1. So going from here to there, that's 1, 0, 1, 1, which we can find in choice D. Question 36 says a diagram shows an electromagnet near a coil of wire connected to a voltmeter. The reading on the voltmeter is 0. The switch is closed. The electromagnet magnetizes quickly. What happens to the reading on the voltmeter? So there was an instant change in magnetic field. So this causes an induced voltage, so the reading will increase. But as it is connected to a direct current supply, the current will become constant and the field will stop changing. So there will be no more change in flux or no more cutting of the field. So the voltmeter will read 0 again. So it keeps increasing. No, it does not keep increasing. It increases, then goes back to 0. It quickly increases and stays at maximum, not stays at maximum. It quickly increases and then decreases. Yes. It stays at 0? No, because there was an initial change in flux. So the answer here is C. Question 37 says which graph shows the voltage output of an AC generator with the peaks and zeros correctly labeled? So an AC generator would not produce A and B. It would produce a sine wave or a wave-like graph. But labeling the peaks are correctly labeled in both. Zeros are not at the bottom, zeros are at the x-axis. So the answer is D. Question 38 says 3 students are describing the structure of an atom. Student 1 says all the positively charged particles are in the nucleus. Yes. Positive electrons are in the nucleus. No, electrons are not positive and are not in the nucleus. Negative electrons orbit around the nucleus. Yes. So which statements are correct? So that's 1 and 3 only. So the answer is C. Question 39 says when alpha particles are incident on a thin metal foil, most of them pass through undeviated. What does this observation reveal about the nature of the atom? So the atom has a dense nucleus. That is true, but it is not related to this result. The atom is mostly empty space. Yes, that's why most of the alpha particles pass through undeflected, because they did not interact with anything in their path. The atom is very small. No, the nucleus of the atom is positively charged, not from this observation. So the answer here is B. Question 40 says a laboratory worker measures the count rate from a radioactive source. He records his results in a table. The average background radiation in the lab is 8 counts per second. What is the half-life of the source? So if there is background, we need to remove the background from the readings. So taking the 100 count per second, we subtract 8, we get 92. Then we take the 92, we divide it by 2 to get the half-life. So 92 divided by 2, that's 46. But in order to check the numbers in the table, we need to add the background again. So 46 plus 8, that gives 54, which actually exists in the table. So going from here to here, that's 1 half-life because we divided by 2 one time. And that took 2 minutes. So the answer is 2 minutes and B. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing and I will see you in another video.